Welcome students. Now today we will learn how to find the spring constant of a helical spring here. This is the spring by plotting load versus extension graph. We will take the observation from this apparatus. This is spring constant apparatus. So we will use it and then we will find this is spring constant. The objective or the aim of this experiment is to find the force constant of the helical spring by plotting graph between load and extension. I am just repeating it the way you will write, how you will write on your notebook. And then apparatus used or required, that's written over here, but you should also consult your lab manual, any CBSE lab manual. And then this is the formula used, that is restoring force divided by the extension. In this way we will find the spring constant. Now here the apparatus is set. You can see here that the pointer is giving you 0 reading, that is 0.0 reading in centimeter, and this reading is recorded over here. This is mass. This mass which is here on the spring hanging, this mass is assumed 0 because we are going to start from the 0. We are taking this 0. So initial, this is extension mass, is a standard mass used to set the system in order to take the observations. So it's clear that our first reading is for standard mass which is taken 0. So this is the net weight is assumed 0 because this is, again I am repeating that you should not be confused by this, that we are assuming that our spring is now set to give us the reading. Spring is also, you see that in this condition we are getting spring being set to a particular condition. We are appearing to be a almost perfect helical spring. So this standard mass is kept to set the apparatus working. So this is assumed 0 and the value of the same is recorded over here. You can see that 0.0 and 10 to the power minus 2 because the reading is in meter. So it's multiplied by 10 to the power minus 2, and same thing is done here in case of weight and mass also. You can see mass is actually measured in gram, so gram is multiplied by 10 to the power minus 3, so it is measured in kilogram. Same thing with weight and force also. Actually weight is taken by multiplying by 9.8 with this value in kg, so weight is also in Newton because we are restricted to use of SI unit, which is advised to us to use all SI unit in all kind of calculations and final conclusions. So we are starting the work in SI unit itself. Now we will add first mass into it and we will see that what happened, how the reading changes. You can see that it is somewhat 1.2, in fact it is overlapping the 1.2. so this is 1.2 centimeter. This is the reading recorded over here. For first reading we had used 550 grams, so 50 to the power minus 3, it is in kg, and when multiplied by 9.8 in Newton, it is 0.49 Newton, and the extension is 1.2 centimeter, which is 1.2 into the power minus 2 meter. Now we will add more weight into it and record the readings, and I am showing you how this experiment is extended for different masses. 100 gram, now 150 gram, it's here, you can see it, and this is now 200 gram. Yes, take the next one. It is now, this is 250 gram, and you can see this is 250 gram. It's coming 6.8 or 6.9 somewhere. So these readings are recorded here in the table. You can see First reading was shown to you, and next readings 2.5, 3.9 and 5.3, and the last reading 6.8 in centimeter, then converted into meter. This is our table. So now we will complete the table. In order to complete the table, now we will start decreasing these masses and we'll record the readings. Just take out one of the mass from it. First mass, take out one of the mass from it. You can see that what's the reading. You can see it. It's 5.4. 5.4. This is 5.4, and there will be no change in 6.8. That will remain the same because no weight was withdrawn from the hanger. First phase was withdrawn, and then 200 gram was hanging over there, 50 gram was withdrawn. So that's why the next load decreasing, when we are decreasing the load, next reading will be recorded from the bottom, and it is 5.4 centimeter, which is 5.4 into 10 to the power minus 2 meter. When another mass is withdrawn, you can see that it's 3.9. Previous reading was perhaps also, yes, that was 3.9. So the same reading will be recorded. In this way, all the readings in decreasing also completed. You can see that only one variation was there. For 200 gram we received, that is 5.4 instead of 5.3. So there is very small change. Spring is almost perfect because during Corona it was not used, so it's functioning well. There is nothing wrong with it. So the readings are giving almost same reading for increasing and decreasing. There may be slight differences while you are doing the same experiment in the lab. When you decrease the load, when you keep particular load on the spring, it get extended, and when you decrease the load, it can retain and it can contain some extension, and that may be reflected. Means after decreasing the load, you may have some increased value, some value like this. It was when we were increasing the load, it was 5.3. When we were decreasing the load, it was 5.4. The same phenomena may appear in other readings also, but here in this case it is not like this, so there is no issue. Now the table is completed. You can see how we have calculated the extension. First reading for zero load was taken as R0, and then extension was taken as R0 minus R0, that is first extension is 0.0, and then R1 was the next reading. Minus R0 means upper reading, that is R1 minus R0 is taken in this way. This R1, R2, R3, R4, R5 need not to be right over here. Neither this is required to be written R0 minus R0, so it will be wiped out and the only remaining things will be here. Now this is the proper way to record the readings and calculations. I have wiped out that we have already put it in best form. So this calculation also shown over here should also not be there in the table, just it will be also gone. Now here also see that the mean of 5.3 and 5.4 was 5.35, but the accuracy is limited to first decimal place only, so it was rounded off because the 5 is there and the digit before 5 is 3, which is an odd number, so there will be no change in that. 5.3 will remain, so we will wipe out this also. We will just record only the final value. This is 5.3. So all those readings recorded just to show you how we are doing it, now taken back, so there shouldn't be any confusion to you now. All these tables readings should be clear to you. Now that rod is off, I think it should be more clear to you. This table is more clear. Now we will plot the graph between this is force versus extension, and we will show how to calculate this spring constant from spring constant as per this our purpose, how to calculate the spring constant with the help of this graph. Now these readings are marked on this graph. You can see that scale was chosen on x-axis 4 centimeter is equal to 0.49 Newton. So here you can see these 4 centimeter are taken as 0.49 Newton, and on y-axis you can see that 2 centimeter was taken as 1 centimeter. Some students write this first 2 centimeter instead of 2 centimeter 2 unit, but the unit of this graph is in centimeters, so you should write 2 centimeter instead of 2 units. So here 2 centimeter is equal to 1 centimeter. On graph it is possible that 1 kilometer is taken as 1 centimeter. There is no issue. So here mathematically it may not be true, but in physics and in graphs there is no issue. So here 2 centimeter is taken as 1 centimeter, and on the extension line, this is on the y-axis, you can see that these points are now just to be marked, but the points are already plotted. So here on this graph, so on y-axis the points are marked, standard points, that is 1, 2, 3 and 4 and 5, 6, 7 centimeters are also marked. You can see that these graphs are these points which are plotted on the graph are approximately in straight line, but we have to find out a best fit line for this graph. Need not to be this line passing through all points, but it should represent all the points. Means some points may lie above the best fit line and some other points may lie below the best fit line, but the line must pass through the origin. So that kind of line we have to find, that it should pass through the origin and it should represent the best fit line for these particular observations. Means may not be passing through all the points or even the one points, but representing the points most appropriately. Now see, this best fit line is drawn, and you can check what I was saying, that this line is not passing through all the points, but it is passing through origin, and also some points are above the line and some other 2 points here you can see that are below the line, but no other line was possible which is representing all the points along with passing through origin also. So this is one of the best line, that's why it is called best fit line. Now in order to find the ratio of extension and load, it is for that purpose, or the slope of this reciprocal of the slope of this line will give you the spring constant. For that purpose we will choose any 2 points on this best fit line. The condition is that the points should be chosen in such a way that the more than half of the length of this line should be covered, and also the points should not be chosen those which are observation point are to be chosen non-observational point, and point must be exactly lying on this best fit line. Meeting this criteria, you can see that 2 appropriate point we have chosen. You may choose some other points too whenever you are doing, but you can see that A and B are the length between A and B. You can see this is greater than half of this whole line from origin to the end, the last reading. So the distance between A and B is greater than half of this, and also you can see that these points are lying on the line and best fit line, and you can see that these points are not the observational points. From this chosen points, you can see that now we will calculate the value of K. K is actually whatever this difference between the force we found. This is delta force. This is this length in its particular unit, and also this OB, which is change in extension, which is also in its proper unit. Simple mathematical calculations and application of physics rules. You can find the value of spring constant of the spring used. It is 3.7 into 10 to the power 1 Newton per meter. You can see that how the values are substituted. AO was the length and OB was the length on the y-axis, AO on the x-axis. The values were written as in centimeter, then scale was used. 4 centimeter was 0.49 Newton, so 1 centimeter for 1 centimeter 0.49 by 4 centimeter was multiplied. Similarly in the denominator, so mathematically when evaluated, you find 0.3675 into 10 to the power 2 Newton per meter, but our values in the table what we use, you can see here in the table, our values are at most only of two significant figures, because mass was 50 and then 100 and 150, so significant figures are 2. And similarly on the centimeter scale, we are having extension, these are the extensions, you can see 0.0, 1.2, so these significant figures here are also 2. So our answer should also be restricted to the same value, and for that purpose we have rounded it off to 3.7 into 10 to the power 1 Newton per meter. In scientific notation we have written this value, and this is the perfect way of writing the final result. This is 3.7 into 10 to the power 1 Newton per meter. Though you have to record all these experiments from your lab manual, and proper guidance you can find in the lab manual. I am showing you a sample of the previous records made by some of the students like you. So you can see that a diagram is to be drawn, and these things are to be written in the observation table. Here was not good, so I have hidden it, so you can see that the way we have drawn the observation table you already know in this video. So that observation table should be drawn to record the observations, and then the result is to be recorded as 3.7 in 10 to the power minus 1 Newton per meter, and then some precautions and sources of error are to be recorded, and better you take these precautions and sources of error from your lab manual. Thank you very much for joining us today. It was, I think, the last in a row currently, because till your examination we are not going to add up any more experiment. These 4 experiments you have to write currently, record, and hopefully that you will come to offline mode soon. So we will be having direct interaction in offline mode too, but we will continue recording the experiment, and whenever a new experiment will be recorded, we will ask you to see that. So keep subscribe to this channel, and keep referring to this time to time. You will find some good supporting material for you. Thank you very much again.